Hi guys, in this lesson I will show you the way to solve triangular looking shapes, filling three-sided holes, a concept of a degenerate or converging points, and the way to avoid them. As usual, quick theory first and a practical example in the end. If you're interested just in example, please use these timestamps. So, what's the deal with triangles and triangular surfaces in general? Let's start with the fact that they technically do not even exist even if you're looking at them right now on your screen. So the reason being, every NURB surface is two-dimensional domain of points in u and v directions, and a surface that constructed along this domain. Therefore, all NURB surfaces are four-sided. There are no exceptions. This is a fundamental rule for all non-uniform rational geometry. So you're looking at two four-sided planes, one of which to the left has one of the domain rows squashed, overlapping CVs one over another, and the one to the right was trimmed, showing you only the triangular piece. I will use it as a reference of a proper surface. Now let me inspect the surface in question, this one. So as you can see, I activated the isoparams of the surfaces to represent the underlying structure of the surface. Because isoparams, they basically showing you visually, they represent you visually the domain of points, and you may imagine that points are sitting on the intersections. So if you look at this surface, you will notice that the domain is converging to the top. It's not straight like here. And in fact, if I will activate the CVs, the control vertices, you will see that, yeah, there is definitely a peak. There is a one CV, and then there is four, and there is four, and there is four. Like in comparison here, it is a flat plane because both of them are flat here. And it just trimmed. So Alias performed the Boolean operation and just hide parts of the plane which we are not interested in, using trimming operation, as I said. So if I will now select the point, you actually see here in the information window that there is not a one point, there is 4 points overlapping each other, so sitting on top of each other. That thing called a CV multiplicity. If just a few CVs are overlapping, it's called CV multiplicity. If the whole row of the domain, or U or V domain, doesn't matter, is overlapped, it will be called as a convergence or a degenerate point. It doesn't matter how we call it, all the terms are valid and used, just depends on the on a studio, on the bureau you're working with. So this is a bad thing. So it's not desirable. And there is a lot of reasons why. The degenerate point is a root for many, many errors, even though that the Alias itself can produce them in no time. For example, this one I did myself by just, selecting the row and squashing it. But you can do it using just the skin tool. So as you can see, there is two curves, right? And I can use a skin tool. Just use it like this, and basically I will get the same result. So as you can see here, we have a few CVs overlapping each other. Now, as I said, this is not beneficial. It is a root for many errors, but it's not that plainly visible, especially on the simple geometry. Now, this is a very simple geometry. They just flat, and if I will turn my zebra stripes or just look at the standard shading, you will not see any visual difference. So there is a lot of a structural difference, but visually they are identical and there is no visual errors. More so if you look on these two, which is the same. This one is converged and this one is the standard one with a trimming operation, but they are bent, and they are bent from the converging point. And compare the two, you still will not see any difference. They behave the same way, they look the same way, and you don't see any visual errors. More so here, for example, once again, this is the same pair. I extracted the curve from one of the sides. And here actually you see that the surface with the degenerate point actually produces me a better curve than the trimmed one, which I suppose is not a surprise for you because, the trimmed surface always has a more complex curve. and the degenerate surface, it has a true edge. So we just replicating the true edge of the surface. But once again, it just does the job. There's no problem. Here, for example, it's even a little bit more complex example where the bend of this triangle is not up but down, and in fact it's not just bent but actually constrained to this surface with tangency. So if I'll activate the history, you're going to see that the continuity is set to G1, it's tangential, and in fact it works. So I literally aligned or constrained as a tangency this squashed row of CVs, the degenerate point, and it works. Nope. In comparison here, there is the proper one on trim surface. And once again, you will not see a difference. It works the way how it's supposed to work. No errors. And on top of all of that, there is the profile, which is run by this curve here and here. And I will run it with the curvature continuity along, and it works. So it may give you the false sense that, well, that's actually not that scary and the degenerate points may exist and this is not a big issue, right? Well, the problem starts when it's a little bit more complex than that. And it's not driven by the surface structure itself when you change the CV structure by manually moving the CVs, but actually using curves, the B-splines, to construct the surface, because this is exactly what we'll be doing in 99% of modeling. So if you look here, I have a little bit more complex example, two of them. And there is the surface, which actually constructed through these array of curves. And they all have a different direction. They curved in the different direction, Euclidean space. So it's a little bit more complex than any of those. And when I created the surface, I used skin for that. So I used the skin, I created the skin between this, let me just hide it, between this curve and this curve, and then aligned tangentially, opposite or positionally to this one. I will get my curve, or sorry, surface. And if you look at this one, now you will see the strange behavior which it just caused. So first of all, you're going to see a very aggressive bend towards the converging point or degenerate point. And if you zoom in closer and look at the peak, you're going to see that it's not just bent towards it aggressively, it is distorted. Because of the CV multiplicity, it just starts to bend and morph to the very undesirable result. And that's caused by the fact that there is a CV multiplicity or degenerate point in the top. There is no way around that. If you did the surface this way, you kind of screwed. And the surface is, well, butchered. There's not much you can do to save it at this point. In comparison, there is the same triangular piece, but it constructed using the square tool, and it's possible because I took this curve that they were absolutely identical and just detach it, giving myself additional surface and giving the square tool additional side. And as you can see, it get absolutely different result. It doesn't have these pinching, it doesn't have this aggressive band, it's more natural. Although this is not the proper way of doing that also. So even though that it is a square surface and it has somewhat like a manageable domain, it's much better, it's still not the ideal situation. And I actually made one of these examples before in the cross-align video. I'll put the link in the description, where I mentioned that I will do it just as for the quick sketch, but not as a final result. And there is a reasons to that, why this solution is not really good also. Now it's bending a little bit, but it's not the main issue. But even still, is that this one is not the proper way of doing that, and I will show you the proper way in a couple of minutes. It's still much better than the converging point. So converging points in these situations is a no-go, and in general the converging points is something you should avoid all the time. There is now no single benefit to having them. So sometimes you can just speed up the process. You're doing sketching or quick proportion discovery, and you just need something. Okay, you can put it, but then you delete it and do it the proper way. And about the proper way, let's go to the next example, the practical one. I'll actually show you how to do it the proper way. So, okay, so we have a form. It resembles, I don't know. Let's imagine that this is a boat, the whole of the boat. So you have one side and there will be another side mirrored to this. And I already have the main surface, and I need to cover this hole using these curves. So right now it's empty, I need to fill it. Now, if I will decide to go with the converging point using 3 sides, or basically 4 sides, but one of them will be squashed, I will not get a proper result. Never will be able to. Let me actually quickly illustrate. So I will use the skin tool. I will create a surface. Let me bring, I don't need to bring, it's already fine, right? Yeah, okay. And then I will align it, constrain it as a, no vectors, with position influence set to 1 to my main surface. And as you can see, even though that we have a curvature here, if we look at the peak where the convergence happens, you're going to see that, well, something strange happening here. And there is not much I can do about it. Now I can, can try to, let me look at the history, to manipulate with this a little bit, but there is literally no way that I can do it the proper way, that the surface itself will not bend. There is always will be a bend, and it can be more visible or less visible, but that's because you're going to see it right here, right? So let me actually change the shader, and you're going to see how it bends here, right? Yeah, that's horrible. And it doesn't matter how hard you try, there always will be an issue. It can be, once again, less visible or more visible or less visible. It always will be with you. It always will bend, and you're going to see this stuff. You can't get around that. So this is, you're going to see it here. So this is not a good solution. Well, what is the alternative? I believe you already guessed that the alternative will be to fill this 3-sided hole with 4-sided patch, like in this example, very fast. And I mentioned that this is not necessarily the great idea also, specifically doing it this way, but let me actually show you what will happen. So first I need to have additional edge. So right now I have 3 edges, I need 4 edges. So first of all, I need to decide where I want to do the 4th edge. I can do it here, here, or here. Let's start with this one. So I will use the fit curve and create the curve. And let me just create another one, just for visual reference and the guidance for us. And then I will create a square tool. Square tool use all of these curves which we created to create a square surface. So 1 second, 3rd, 1 second, 3rd, and 4th. Okay, now we have a surface. Now, if I'll activate the zebra stripes, you're going to see now we don't have any issues here. It looks fine. No issues whatsoever. That's great. What's about this side? Well, right now it has some bend. We didn't really bring any constraints except of the position. So now I need to align it. So let me delete the history, and then I will try to align it. Now, first, let me try to align it the standard way, right? So here it is. I will use partial, and you're immediately going to see the issue here that partial alignment will not work. Why? Because the angle is too wide. Now, and there is another really important concept that the Alias and its kernel is pretty powerful in terms of the aligning different surfaces together, but it can't do extremophiles. So there is a big range of motion, but in this specific situation, the angle is too wide. In ideal situation, if you want to have a pain-free constraint, the angle at which you constrain the surfaces should be 90 degrees. Obviously, this is not always possible, not even always possible. It's rarely possible. In most cases, you have a complex surfaces and they are all under the different angles. They are elongated. There will be, wide angles. There will be really sharp angles. And it will work until you just basically overkill it. And in this situation, the angle is just too wide. The Alias just can't do anything. It's just failing, basically, to produce the proper result. Now, is there a workaround? Yes. The workaround will be to constrain the movement of the CVs in this situation using the vector. So that's what I'm going to do is I will click on the vector and I will use the normal direction for the vector. And as you can see, it doesn't really butcher, I don't want to butcher my CV structure anymore. But at the same time, I have the problems with tangency and the curvature. I can increase the amount of degrees, but as you're going to see, it doesn't really help me much. We still have an issue. And this issue, once again, comes from the fact that the angle is too wide. So it will be an angle of 120 degrees, 130 degrees. Alias will be able to create the constraint almost without any problems, without, manual CV manipulations. But it's wider, and even the vector projection will not give you, not the vector projection, vector constraint will not give you the proper result. So what is other options for us? Let me revert and delete this curve. It will be really difficult for me to do, almost impossible actually. So what is the other option? Well, the other option is just, instead of cutting it here. Well, let's do that. So I will detach the curve somewhere somewhere in the middle, like that. And then I will just delete these curves and I will use the square. I will create the square this way. Right, and now I will align as a curvature. Now, let me check this, and whoa, we have a curvature here, no problem, but now we have the problem here. The reason being is that now it's not really working properly because our flow of CVs is wrong. So it's supposed to flow in this direction like that, and we have the angle here. So now we have this pinching, and once again, we always can just manually try to adjust that to some extent. But once again, the more and more degrees you need to bring to accommodate for the curvature which we're going to have here. So let me just realign that again and bring, for example, more degrees here, like that. Just delete that and then just manually try to adjust this piece, and to some extent we can do that, and it's just actually a little bit better than it was. The CVs is a little bit over the place, but you can do manual adjustments and eventually get there. But only this approach will work only if, well, the surface is relatively simple and you don't have another continuity constraint on the top. Because remember, if you want to try to align this edge to something else with tangency, for example, you will have the same problem as we have before. It's just too wide of an angle. If this is a position, to some extent we can. Now, it bends, right? So you probably will spend quite a lot of time moving CVs around, trying to just, but yeah, it's much better. All right, what is the proper way of doing that? The proper way of doing that, let me just delete this and just actually delete this short curves and bring my original ones like that. So the proper way of doing that is doing it as a square, so almost the way how we did it, but this time we will manage our angles. And before I will proceed, I would like to mention that the surface you're looking at, this one, is not just a random surface. This surface was designed the way that it will connect to the point of convergence. It's not just randomly slapped here and I just call it a day. It was moved. These CVs and these CVs were moved the way that it will already starting to bend in the proper direction. You can do it manually as I did here, or you can do the same approach as I did in the cross-align video. But it's supposed to be prepared. Otherwise, you will have your curvature, but it just will not be the good curvature. Okay, so it's supposed to follow the direction and finish. You know, if you extend that somewhere here, not exact, but close to. And I already achieved that, so I took some liberties and did it behind the scenes because there is some back and forth with the CVs. But now, as you can see, I have these isoparm in the middle, and I know I already tested that, and I built the surface this way that these middle portion of the surface, its center, the isoparametric center, is actually connecting. It kind of flows into the edge. Once again, you don't need to be kind of one-to-one exact, but the rough direction. That's why I kind of put these ones a little bit inwards and these ones a little bit outwards. So now let's build the proper connection here, to fill the hole the proper way. As I said, we will manage our angles this time. So what I'm going to do is I will create a curve, just the standard 1 degree curve, and snap it somewhere. Now, then I will do not somewhere in the middle on my isopalm. Once again, I know that the isopalm is actually showing me the proper direction right now. So I have these two curves. Let me remove the shading. So next what I'm going to do is I'll take both of them and just a little bit, maybe somewhere here. So when I'm placing these two curves, what I will do is I will project them later on the surface. And the one of the goals for me, what I'm looking at, is I'm trying to maintain my angles that they will not go to extremophiles. So this one is not 90 degrees, a little bit bigger, but not extreme. This one is pretty wide angle, but it's not 180 degrees. It's a little bit shorter, you know, it's not that wide. So I'm trying to avoid the situation where Alias will struggle because of the angle is too sharp or too wide. And always remember, always strive for close to 90 degrees. Now, in this situation specifically, it will be impossible. I can make the 90 degree angle or close to 90 degree angle here. This one will be too wide or this one will be too wide. So I need to sacrifice something. And I will be sacrificing this angle. And the reason for that is because this surface is, because I will be projecting on this surface. And that means that Alias will have less problems aligning it rather than creating these edges. So, what's my next steps? First of all, I will project the curves, but not curves on surfaces. I will project the actual curves. And not a lot of newbies, I believe they just forget about this feature, that in the project tool, you can project not only curves on surfaces, you can project curves. And this is exactly what I'm going to do. So I click on the curves and I will, where's the direction? Direction will be Y. And I will project it, not in the normals, I will project it on the Y direction. In this specific situation, it will be a little bit easier for me. So let me project this one and let me project this one. So now, as you're gonna see, I have a huge deviation, 7.2 millimeters, 7.2 millimeters. Why was that? Well, that's because my curves here are only 1 degree. So let me increase the amount of degrees here. Okay, so always strive for minimum amount. Now this one will be free because you always can increase the amount of degrees when you create the surface, so this is not a big deal. But the smaller amount of the degrees you have, the cleaner the surface will be. And once again, if this is not enough, you always can bring more. So same here, how many I need here? 4 degrees, okay. So as you can see, when I projected it on the Y direction, let's look at the Y direction, it's actually straight. But if you look at the other directions, you're going to see that we have this band. I'm not bothered about that too much. Actually, I'm not bothered about that at all. I can try to project it on the normal direction and I will succeed, but it probably will take more degrees. So now I have these curves here, and they are actually, let me just turn off the shading back in. You're going to see these ones, these green ones, they are the actual curves. They are not curves and surfaces. And this is great because they are very clean. So now I can use them, create my square, and as you can see, now I have angle here. I will create my square, it will be very accurate, and it will be already positional to my driver, to my main surface, which I will be constraining to, which is very beneficial. If I will project just a curved surfaces, then most likely I will force to rebuild them, and then just basically an extra step. So now I will use square tool to create my square. So 1, 2, I will pick the projected curve, this one, and the projected curve, this one. All right. Now, as you can see, it's really familiar to you because just a couple minutes ago we did the same, really similar example, but the edge was here, right? We have a really shallow angle, 100-degree angle, basically. Now our angle is curved, so it's sharper. And this is the difference, it's just a night and day difference, basically. Okay. What am I going to do next? Now, I know that they're already positional, so I don't need these curves anymore. I can just delete them. And then I will project. Now I can project. I deleted the curves, the original curves, the curves I created, everything. And now I will project. This time I will project curves and surfaces on the normal direction. And it's supposed to be flawless. So this is one. This is the second one. I will use continuity constraint and check my positions. And yes, they actually positional. So now this is the curves and surfaces. They are lying on the surface, and they are already positional. And that means that now I can constrain that as a tangency or as a curvature because they are marking the part of the domain on the surface itself. So let me do that. I will use align tool. I will use G2, edge, not a project. I'm already projected it. I know that it's positional. So I'll go to the edge, click on the surface, and click on my curved surface, like this. So now, as you're gonna see, now I will not be changing the skewing, the edge, the outer edge option. So it's set to skew, and I will keep it here. If you're interested about the difference between skew and edge, I made a video about that. I will put the link in the description. So now we have an angle deviation. It's not a big one, 0.01, and we have a curvature deviation of 0.6. I can probably move the CV influence back and forth and see which one works better. Looks like there is just not enough degrees. So first of all, I will go into the blending because remember, this curve is 4 degrees, this curve is 3 degrees. So when we created the surface, now we have this additional row of CVs which are not in effect on the curvature. And I would like that all my surface will be contributing to the curvature. So it will be smoother. So what I'm going to do, not just smoother, the proper shape. So what I'm going to do is I'll go to blending and I will use additional extra CV row like this. And most likely I will change the blend factor back to 0. Let me check the zebra stripes and just move it back and forth and see what kind of a contribution is better. So this one gives me a little bit more of a natural transition between these two curves, and this one a little bit forced, and try to streamline it a little bit more. Now, it basically based on your design intent, I probably leave it like this and call it a day. Now about the tangency, as you can see, we still have problems. So I will increase the amount of degrees from 3 to 4 and probably from 4 to 5. And I believe that is good enough. Now, what I'm going to do next is I will project this part. Remember, we're not projecting it. It's locking tangency. So I will do the same thing, but on this side. Let me actually remove the, bring some transparency, sorry, to this. Okay, so let me do that. And now we project it on this side. Now this time I will not be getting any additional blends. It's already blended. The only problem is that now we have curvature here. We lost tangency on this side. Now I can remove a little bit of my position influence, just playing with this one, and then bringing additional degree, maybe bringing additional degree here. Or if I'm actually looking that there is too much degrees, now at this point there's an options for me. I can either manually remove the error, and there is not a big error at all, 0.08, or I'll just bring more degrees. Now, I do not want to bring more degrees if the deviation is so small. So, because it will make my life harder if I will decide to tweak the surface. So what I'm gonna do is I will leave it be, I will delete the history, I will activate my CV structure, and actually move this, activate it. I'll just move this a little bit. Let me just increase the, decrease the sensitivity, and just, yeah, here we go. And that's it. Now we have curvature on the both sides. We have the decent angle here, and the surface is filled. Now let me go back to the transparency and let me trim this edge. Right. So now we have the surface, which actually can be aligned further on the other side. So here, if I decided to, or here, if I decided to have the clean edge, there is no strange rerouting of the CV flow. And now, of course, I can play with the surface structure itself, because maybe I just don't like something. Let me just activate this. Sure that I deleted the history. I can play a little bit with it, so I can move that up and down a little bit. It's pretty much on the same spot, in the proper spot, but you always can do some small adjustments if you decided to do so. Just straighten the holes maybe a little bit, maybe make additional kind of crown in this part, or maybe less crown. It really depends on what's your intent. Okay. And now we have the proper connection. So the only thing left for me, let me just go back to the original state, to default shader. I'll just, as it is symmetrical, I can just flip it and project it on the surface. Like this, trim it, and then let's take all of this and flip it on the other side. And here we go. Now we have kind of somewhat a boat, right? Whereas more importantly is we created the proper connection, and the connections like these are actually very, very popular and exist in a lot of products. So it can be from automotive industry, cars and stuff, or it can be consumer electronics like hair dryers or kitchen knives or something. You will find this a lot, and knowing the proper way of filling these triangle shapes is very, very important. And as you can see, this is not really difficult. It's actually very simple, and that's why I would like to get to the conclusion and just remind you what is the key here. So, as a conclusion, convergence is a bad thing, and you need to avoid it at all times. You need to fill three-sided holes with four-sided surfaces. And not just that, but you need to care about your angles. Too wide or too narrow, and Alias will fail. And that's pretty much it. So yeah, thank you very much for watching, and I will see you in the next one.